Happy New Year. Alrighty, I'm not really in the mood for this. Greetings the Astro 30 and Happy New Year for 2023. I've received a package and this is a basic sine wave, triangle and square wave generator kit. Cost all of about 15 bucks from Amazon.com. Now I will preface this video with this was actually filmed 21st of December 2022 because I received the package today, but it's not due to be uploaded until the new year. But my original greetings of salutations of Happy New Year still stand, if that made any sense. I don't know if it did, but I'm going to unpack this package here. We've got some components which are all just loose. Three-way header, a potentiometer. I hope they're all the same value. I don't know offhand. 503, so that's 3 zeros, 50k. 50k. 104, which is 100k. So I've got to remember there's two 50ks and one 100k. Let me see if my EEC numeration is correct. Got some pretty knobs. An IC, and it's upside down. The electrons are going to fall out. It's an XR2206, and that's the actual name of the kit. If you want to search for it on Amazon, is an XR2206 function generator. There's no schematic as far as I'm aware. You can find one online, but it's basically following the data sheet of this IC. It also comes with an acrylic case. That's going to be fun pulling all that junk off to reveal the clear acrylic behind it. Always fun. I've never liked playing with those. A jumper. There should be another one around somewhere. Oh, there it is. And a circuit board in whatever this is. And it's a small board. At least it has 4 mounting holes on either corner of the board, which is nice. Fairly basic, should only take around about 15 minutes to assemble. It's not that difficult, but it's not warped either. It's nice and straight, so I'll put that to the side for now. I hope I supplied the standoffs for that. Oh, there is actually a schematic. Well, as basic as that is, it is basically following the data sheet. So I'll leave this on the screen here. I'm not going to talk too much about it because there's the XR2206 CP control IC there, which generates your sine and your triangle outputs, and also does generate the square wave just by changing a couple of jumpers. The only annoying thing about this is, I farted, you have a header to select what frequency range you're in. So it'd be like, I'll explain it when I come to assemble it. Here's the two jumpers over here for triangle and sine, which selects whether it's sinusoidal or triangle. But it does have a square wave, a sine or triangle out. So there's two separate outputs here for if you just want square wave, you put it on this center pin. If you want the triangle or sine, it has to go on this outer pin, and the ground's over here. I thought there was actually a times setting, like whether it's ×1, ×10, ×100 in frequency. It might be this here, that might be the header for that. Because there is two jumpers, so one's for over here and one I assume's over here. But there's not much more information on it. That connector's not even marked as anything, so that's really hot. That's really handy. But you've got your output amplitude here, the fine adjustment of the frequency there, and the coarse adjustment of the frequency there. And also, they're not marked. So I don't know what that's supposed to be. I do apologise, they are marked. It's R2, R7 and R8. So R2 is 50k, R7 is 50k, and R8 is R100K. So that's good to know. It takes a DC 9 volt supply, which is this jumper, well, this jack connection over here. So you just need like a plug pack capable of 100 mA or more, and you should be good to go. So I'm going to set the soldering iron up. I'm also going to do a component check to make sure I've got all the components I need, and we'll start assembling this bad boy. Alright, I believe all the components are there. They didn't supply me any standoffs, but they did supply me some nuts and bolts, but I'm assuming that's for the case, or I'm confused. No, it looks like it's for the case, so I'm going to have to figure out what I'm doing here. But if you don't know what a resistance is or how to read it, just measure it with a multimeter. So bring the meter into shot there. I'm a little bit rusty at making videos, especially on the desk, because I haven't done it in a long time. And my multimeter probe's broken. Huh. Oh, that's annoying. At least I've got another set of leads. I have to buy a new set of leads for this meter now. But anyway, the resistance of this is, survey says, 5.1k by the looks of things. And that is listed, and so there should be a 330 ohm resistor and a 1k in there, so they're in the bag. So I'll start with these 5.1 Ks. Now it is listed in the parts list here because it's not marked on the board what the resistance is, so this is important. So I'll just move the meter to the side. So I'm not going to take much video of this because R3, R5, where the hell is R5? Over there. Because I don't really see much point of taking lots and lots of video of me assembling such a simple kit. I will just bring you back when I've actually got some progress. But we start with the low profile components first, such as resistors, and then we'll move on to other stuff. I've also got a new soldering iron stand, so it makes life a lot easier now. I've got my iron set for 380 degrees Celsius, which should be more than enough for these type of traces and what's it called, pads, because I don't really want to overheat components. It should still give me a decent enough soldering job at that temperature. That's assuming that the scale on this T12 is accurate, which is debatable. Okay, so now I can cut off the excess. I'm really annoyed about those multimeter probes now. Don't know how that happened, because the negative lead is bent and the positive probe's just gone. I'll have a look online in a minute and see if JCast sell multimeter probes by themselves. I'm pretty sure they do. I might buy a set next week or so. I mean, I've got the ones off the desktop meter, so they're interchangeable. They fit in each other, so I mean, that was good English. I really need lower profile cutters, because that was cut really, really bad. They've supplied me with an IC socket, so I'm going to use it with bent pins. Of course they did, and I farted. Right, so put this the correct way around. And it didn't stay in there. Of course it didn't. Why would it? I mean, for me, well, for you guys this probably would only take 15 minutes, but for me it's taken me a little bit longer because I'm filming it. If I wasn't filming it, then I wouldn't have to take so long. Okay, there's the IC socket. Alright, next, because I can, I'm going to install the headers, because they're probably the largest profile components. Make sure I put them in the correct way round, like the line's going long ways. See how good I am. Not very good at all. One stayed in there though. Okay, one's in. Try and get this other one back in. Okay, and just the same as the IC socket, I can now go along and finalise all the joints. I'm going to do that off camera. Done like a dog's dinner. Now, I don't know if I said it in the beginning, but I'm going to put a link in the description to the Amazon product listing of this if you want to buy one. I did buy this when there was only 2 left. I will have a look around by plugging in the XR2206 function generator and in Amazon, see if it comes up with other pages of a similar item. There's probably several different links there. Now obviously I haven't installed the IC yet, and I'm not going to. Now the next thing I'm going to install is, I might do these capacitors. They've actually been nice and they've written the IEC code like 104, 105, 473 for each capacitor, so you don't have to do a conversion. I'll just put these capacitors in for now, and then I'll do the electrolytics last. Well, when you know it, a capacitor flew off and landed on my penis, and now I can't find it. Where did you go? Straight onto the floor. I hate that. Now, what was that one? That should be the 473, which it is. So that makes it C6, which is over there. Okay, I'm back on track now. That's masturbatory there. Okay, so we cut the excess leads off here because we don't need them anymore because they're too long. Get off of there. Get off of there, you prick. These wire cutters are way too big. I need smaller ones like I had before because it's awfully difficult to get in there properly. But it is doing the job for now, so probably could use nail scissors too. They'd work. Right, how did we do? Lovely. Starting to look like a circuit board now. Alright, and that's with the electrolytics. C1 is 100 microfarad, which should be this one, 25 volt. What did I say? That was C1. Take note of the polarity. That's the negative, that's the positive. So that one goes there. This is a 10 microfarad. They're both 10 microfarads, both C3 and C4. So that goes there. That one goes there. We can solder them in. And the next thing I'm going to put on is the DC socket, because that's the next in the height of the components, as in highest. So is this connector. So I'll do those two next, because it's just convenient. So next is going to be this connector and this DC jack, which I believe are the same height. Yes, they are. How good am I? Now this one might take a little bit more heat. Well, it may not, I don't know. It's a fairly large area. Okay, so I guess the next thing to put in is the potentiometers. That's the 50K, which is R2 and R7. So this is R2, that's R7, and this one is the 100K, which is R9. So these are going to be fun to solder, if you can get them to stay there. which they will not. So I might do one at a time. And that just fell out. Fun and games here on the Astro 30 with components that refuse to stay in their holes. Like, really? Honestly? And it's a shame that I don't have a DSO at the moment. I do have something coming though to solve that problem, but it won't be here till later. Alright, so that's what we got so far. All the potentiometers are installed and the capacitors are installed, everything's installed. But yeah, actually everything is installed. It's upside down, the electrons will fall out. And this actually completes the assembly. So what I can do now is just plug these jumpers in somewhere. So A, we don't lose them, and B, they're actually connected. So, oops, I bumped the camera, I do apologise. I might stick that one there. That's irrelevant. Okay, I'm going to let things cool down and then I'm going to install the IC last, but next we're going to look at this acrylic case. So that's going to be fun. And yes, just so everyone's aware, you can buy multimeter probes from JCar. There's different types here. I've got the 90 degree with special tips. That's on eBay though. For JCar though, I can get these ones, but the leads they're not at 90 degrees to the device. These ones are, but they're like $27.95, so it's expensive to replace them if you break them. But these are Cat 4. So, yeah, well, yeah. Anyway. Pays not to break them. Although there is these ones which are 17. And they're right angled, so yeah. They're not the same ones the meter came with, which is annoying, but I can't repair. Well, I could probably just cut them off and change the ends, but I'll have a look at that another day. Okay, so here is the front of the acrylic case. Now, it does say text here, but I'm just wondering if it's actually on the acrylic face itself. I hope so. So what I'll do is I'll start by taking off the backing of this, if I can. Yeah, cool. Okay, with that out of the way, yeah, it looks like it is printed on it, so that's good. So I can actually peel this off. I think it's just etched through the cardboard. That's why it looks funny to me. But you've just got to find somewhere to get it started. And this is only one panel out of 6. Smaller ones won't be so bad. But yeah, these big ones can be a bit of a pain. And the paper seems to stick into the middle of letters like O's. So you have to pick them out separately. And yeah. There we go, that's the first panel. Let's get rid of all the paper in between. Numbers like 6s and 0s and stuff. Got to look at least semi-professional here. There we go, that's the front panel. That will go over wherever I put the board, right in front of me. I'll go over there. Not sure why there's a hole. Oh, that's for the panel, you idiot. That goes over there, but I'm still not sure how the board is mounted, although I think I get it. I think I get it. It's rather a stupid way of doing it, but they've supplied us with, well, what looks like 5 for some reason of these 6mm long M3 screws, I believe they are, and not very many nuts. Well, that's handy. I've got a better solution, but what they're expecting you to do is put this through this panel to the board and then use the nut on top to hold it together, which is like pushing the board right up against the plate, the back panel. So what I'll do is I'll continue peeling off all the paper off of these parts, and I'll check back when I've got something to show you. Okay, annoying as that was, I got all the pieces out now. Still got crap in there. Okay, this is the bottom, and I've just noticed that they've actually got a star cut hole, which allows to grip to the screw, so you don't need a nut on the bottom anyway. I mean, they seem to be trapped on the corner here for some reason, I don't know why. I believe I can get a couple of nuts. What's it binding on? Ah, that capacitor. Right. Should have really checked the manual properly, but I don't think it said anything about that. Let's see if it clears that capacitor now. I believe I'm stuck on that capacitor as well. Let's bend him out of the way. What am I stuck on now? Still that capacitor. Don't want to stress it too much. I wonder if I can just back that out. Okay, I had to get a little bit creative. I had to trim off the excess off the potentiometers that was sticking through the DC jack, for instance, and this output socket, just to give it a little bit more closeness, for want of a better term. So I can actually put a bolt and a nut on the inside and a nut on top. So it's less wanky the way that they want me to do it. Alright, okay. Take the board away. So what I mean is, I've got a 10mm long bolt, an extra nut. I'm going to put it at all 4 corners where the board is mounted, because I reckon this would be a better way of doing it than the way they've told me to do it. I mean, the board will still be coming into contact with the plastic work, as in the solder joints will be. They've given me some nuts, so I'm going to... Is that cracked? It's got a line in it anyway. And so all I need to do is just tighten those with a screwdriver, if I can find one. Because I reckon this will be a better idea than what they were trying to achieve. There should be enough clearance for these bolts. I'm pretty sure there is. So note, if you buy this kit, you might want to buy 4 10mm bolts, or a packet of them, M3 bolts, and M3 nut sets. So you've got a better way of mounting it than the way they want you to, because I don't think it's going to work all that crash hot. And then we just use the other supplied nuts, so I'm saving my own stock, to secure the board to the plastic work. I can tighten that up with a pair of pliers in just 2 seconds. Yes, there's screws sticking out the back, but that's fine. They gave me 4 nuts and 5 screws. Someone miscounted. Okay, so I can now tighten this. This is going to be an unnecessarily long video for like no reason. But some of you actually like long videos, or at least I think you do, because at least then you can see all the pitfalls that I'm coming across, so you can avoid them. Now I might install this chip whilst it's handily available. Hopefully this is not a CMOS type IC. It shouldn't be. Maybe I was preempted by installing that because I can't get my fingers in there. I mean, IC sockets are great, but sometimes I hate them, because sometimes you can't get the IC in there. But I got the IC in there. So that's in there. So that when these two halves come together, everything should clear. That goes that one. Yep, that's that side. That's that side. This is a lot easier to assemble than the clock was, like the clock that uses acrylic case. We've got screws and bolts at different angles. Alright, so the minimum this can do is 1 Hertz, by the way, which is wonderful. Currently I've got it to the megahertz range, so I'll set it on the kilohertz range. Well, the hertz range. Nope, that should all clear fine. I've bent those capacitors out the way and there was enough lead length on there to pull them back out the board. So note to self, when you assemble this, you should really lay them flat, those 10 microfarads, or else they are going to get in the way. So then we just put our screw through. Hopefully everything going right. It all works first time when we turn it on. I will measure it with a meter. See if we're actually getting a sine wave output. But we should. You don't have to tighten this too much because it is plastic. It will strip. It's just enough to hold it together. When it starts to feel tight, stop. You don't have to go any tighter. That looks so sexy. And that, I believe, as they say, is that. I don't want to go too far with this. It is bending at an angle, so those capacitors are still a problem. Alright, so it's going to have to come back apart. Okay, this is the 50th millionth time I've actually put it together. I've got those capacitors as low as I can, so hopefully it clears now. I want to. Do I know what I'm doing? No, not really. I'm doing it anyway. Yeah, it looks like everything clears this time. Yeah, it clears just nicely. So note, these capacitors should be laying flat against the board. I mean, that 100 microfarad capacitor there is coming into close contact with the acrylic case, but we're just going to go with it. Now maybe we can finally put this together and test it. Feels like a Tim Shaw moment, but wait, there's more. I've already assembled it once, but wait, there's more. I've got to take it apart again, because there's something still wrong. Yeah, it looks a little bit better than it did last time. It was bent all over the place. It was like bowed, which is not good. That 100 microfarad capacitor, though, you can't do much about. You can't really lay it anywhere. There's nowhere to lay it, because it's just too big. But that's what she said. Okay, now enough of the dirty talk. remember, plastic will strip easy, so be mindful of that. Don't go whole hog on this. Yeah, it's still bowed on this side, but that's because of that stupid 100 microfarad capacitor. I can't, well, I could if I used washers, but you know, it's going to come into contact with that IC anyway, so I'm just going to run with it. It's a little bit, yeah, how you're doing, but then these shiny things usually are. I'll put the knobs on now. Like so. So that's the course, I believe. Yeah, course. Gee, they're shitty potentiometers. Fine. I'll give some amplitude. Now we need a power supply, my multimeter again, which I've put away for some strange reason. And we'll test to see if this thing works. Okay, I do have a 9-volt power supply here. I believe it's the right size socket, looks like it. I want to verify where the ground is first. Just to make sure I got the right polarity, because if I blow it up, I'm going to be pissed off. So I go to continuity. I'll get it on that one there, and the ground pin over here. Yes, it's negative ground, which means it's positive center. So it should be safe to plug this lead in. What would have been nice is if they had an LED on the board, so yeah, you could see that it was powered on. So we'll go between ground and the sine connection. We do actually have 253 Hertz. I don't know if you can see that. I can't see it on the screen. There we go, it's a bit better. I've just increased the iris. So let's see if the controls do something. The fine tuning is doing something. And the course is doing something. Nice. And there we are at roughly 1 kilohertz. Now if I change this from sine to square to triangle, we still have a signal. Good. So now I'll move the positive probe to the square output. It's also 1 kilohertz, which is good, so I know that both the square, the sine and the triangle are working. I'll change this jumper for the range. Apparently it's 21, yeah, 12, 11. Amplitude, I don't know how much it's outputting. But yeah, no, the kit is working. Even though I stressed those capacitors a little, it's working fine. So I'm happy about that. It was worth the $15. Now, I don't know what the actual output signal is doing. So what I'm doing, and that noise in the background is that crappy G5 amplifier buzzing because the lead's plugged in, but it's not actually connected to anything. I'm inserting some of the resistor wire cutoffs into this socket. I need a flat blade screwdriver. That one's useless. Okay, and what that'll allow me to do is stick a guitar lead across the 2 points to test that there's actually a signal coming out of this. Well, we know there's a signal coming out of it because, well, it measured it on a frequency meter. Excuse me. But we want to see how clean it sounds. So I've disconnected the power. The ground is there. Get this lead up off the floor. Find where my DC 9 volts is gone. Turn the amplitude right down in case it overdrives the amplifier. Plug that in. Ooh. Oh, the amplitude's backwards. Great. I'll just okay, that's really great amplitude. So that pot really is the crappiest volume control ever. It's wired backwards for a start. There's not much range on it either. There we go. So that's going to be annoying that the amplitude doesn't really work properly. Okay, that's my first gripe about it. Unless I've soldered something wrong, of course, which I don't think so. Okay, kill that because that's annoying. Well, we verified that it works. How have they wired the volume control here? Which I believe was R2. Yes, it is. Yeah, okay. Here's our volume control here. It's wired as that. In other words, two of the connections are joined together between the wiper and one end of the resistor. They've also wired it with the clockwise in the wrong direction. And it's going across this potential divider between these two 5.1K resistors and ground. Yes, and it goes into the actual IC itself. So that's what the IC calls for. So therefore, the actual way that that's configured is going to be annoying as hell, because you've got really no control over the amplitude of the output. It's either low or it's full on. So that would be my only annoying gripe about this. But yeah, there's not much I can do about it. I believe that's the volume control. Yeah, it's R2. So yeah, it's the volume control, or the amplitude doesn't work right. But anyway, okay. So that's the XR2206 function generator, sine, square, and triangle. Yeah, it's a fun little kit to build. The results of this amplitude pot is ridiculous, but it is what it is. For a beginner, I'd recommend this. At least you've got a basic sine wave generating tool. You don't need an expensive function generator for that. I'll just unplug that now. You don't need an expensive function generator for that. Only if you want to generate a 1 kHz tone at a certain amplitude into an amplifier to test its peak output power. However, with this particular control here, I might on the output have to put a separate attenuator before, like another pot, as an attenuator, just to attenuate the output so it's going between the output and ground, so it's actually giving me more control over the actual amplitude, because this is pretty much well useless. But other than laying these two capacitors here down flat to the board so you've got plenty of room for the case to go together, and you could probably get away with a 16 volt 100 microfarad capacitor that you can buy from JCar or something. You can lay it across the board, either probably that direction, if you can sort of like clear the connector so that the case comes together a little bit better than that. Although they did originally design it that you lay this board as flat to the bottom as possible, but I don't like that, because you're going against different heights of solder joint cutoffs and you're putting stress angles on the board that you don't need to do. My solution's better, but you could probably change that to like several washes to lower the distance that it's taking up, so the board comes a bit closer to the back panel, because there is about probably 1 millimeter or 2 of space back there I've got spare. But yeah, it works. It's not the best construction in the world, but yeah, I still don't like the fact that it's bowed here. I'm not going to continuously take these in and out, because I'll probably end up having to get like longer bolts to put through to circumvent that and put nuts on it if I keep taking them out and end up stripping them. But that'll be something I'll look at a little bit later when I've actually got an oscilloscope to actually measure the output, so I can actually figure out how well this amplitude knob attenuates, for want of a better word. Anyway, I'm just waffling on about crap at the moment, so I'm just going to sign this video out because it's gone on way too long. It's gone on for a million years. Anyway, I'm the Astro30. I hope you enjoyed this video. Please remember to rate, comment and subscribe below if you did. And you can always follow me on Facebook. The link is in the description. If you want to become a Patreon, please do. That'd be great. The link is also in the description. Anyway, this is the Astro30 saying see ya. Have a great day. Yeah, so that amplitude, that's wanky. Absolutely wanky.